Mr. Minnick helping his students with Tracing While Loops Worksheet 3, which on this worksheet here in Python, we are using sentinel values, such as -1, and what else is new on this worksheet that we haven't studied yet from a previous worksheet? Break statements. Right here's a break. When we get to number 3, that's a little tricky. So let's get ready for that soon. Number 1, little code segment here. Look up the modulus operator earlier in our school year. If you don't understand what the percent symbol does, it gets used in one of the exercises below. And let's proceed with number 1. So we have score 0, count 0, sum 0. 3 variables, and they were all set equal to 0 over here. And you can see that reflected. We hit this while loop. And the first, at the top of the while loop here, we have a control expression, score not equal to -1. Well, we're assuming that the user inputs these numbers, 9, 7, 8, -1, but they haven't done any input yet. Right now, right from the get-go, score is currently 0. So we ask, is 0 not equal to -1? True. 0 is not equal to -1. That's the not equal to symbol, of course. So we do go through the loop at least once. We hit this line of code, score equals in input. On an earlier worksheet, I reminded you that you have to take the saran wrap off of a cookie before you eat it. You have to take the quotes off of the 9, the double quotes that made this inputted 9 equal to a piece of text or a string. When they inputted that 9, this int command takes the quotes off. And it turns it into the plain number 9, which then plugs into the variable score, which means we cross that out and put a 9 here, and we move on. The next piece of action here is an if statement. Now this is a review from before. We studied if statements. This if is indented, so therefore it's inside the while loop. And it has its own control expression, which is the same as the control expression of the while loop. So this is true, score not equal to -1. So we now do the code that's in the body of the if, which is in the body of the while loop, which is in a Python program that you can't see the whole program. Count plus equals 1. That causes 1 to be added to our running total here of count. It's a counter statement. That's called a counter statement. Sum plus equals score. We take whatever score is and we add it into sum. So that 0 gets crossed out and that makes that a 9. This line of code is called an accumulator statement. That's a vocab word, I think, in this chapter. I don't have time to write it out here. I'm using my mouse. It's awkward. Accumulator statement. When you're adding 1 to something, it's called a counter statement. But if you're adding some unknown varying amount, it's called an accumulator statement. And anyway, I don't have time to write the word counter here, but that's a little, oh, I put the wrong comment symbol. That's what you do in Java. I needed hashtags there. Don't have time for that, so moving on. We did those 2 statements, so we loop back up to the top. And score not equal to -1. True, 9 is not equal to -1, so we go through the loop again. The next number that gets inputted for score is 7. That goes into the variable score. Is 7 not equal to -1? True, so we're now inside this if statement. We add 1 to count. And we add score to sum. Score, 7, gets added to sum, which is 9, for a grand total of 16, which gets written here. Because this statement works from right to left. This gets added into sum. It's not the other way around. We go back up to the top of the loop, check the control expression, which is currently true. Again, 7, not equal to -1. The next number that the user inputs is an 8. So the 8 plugs in here for score. Pretend that these are like quiz scores on a 10-point quiz or something. And then we check this control expression for the if. It's still true. So count plus equals 1. Count is up to 3. The accumulator statement, sum plus equals score. Sum plus equals score. 8 gets added into 16 for a grand total of 24. And we go back up to the top of the loop. And 8 is not equal to -1, so we go through the loop again. -1 gets inputted. So apparently the customer is tired. They purposely typed in a -1, which they were told to do because it's called the sentinel value. Eventually, we learn how to build programs that have buttons, and they'll click a button to exit something. But for now, they have to type -1. A little annoying. It's the way it was in the 1980s and about half of the 90s. We had to do stuff like this a long time ago. But it's a good way to learn in an introductory course. Anyway, this is now -1 not equal to -1. Oh, right here. We're not up there. We're at this spot right here. -1 not equal to -1 yields a false. That's a false. So we do not execute the body code in that if statement. The body statements in that if, we don't execute them. There's no more adding to do over here. We still have to loop back up to the top of the loop because that's the way it works. And now this control expression, score not equal to -1, also yields a true because score is currently, oh, I'm so sorry. I forgot to put a -1 under here a second ago. That was really a -1 when they inputted that -1. So this is now overall -1 not equal to -1. That's a false now. That's a false because it is equal to -1. And that, therefore, we don't go through the loop again. Therefore, we're done with everything. Oh, there are 2 more lines of code that are not indented here inside the while loop, so we do execute these 2 lines of code finally. Average equals sum divided by count. Sum is 24. Count is 3. You should not need a calculator for that. Therefore, the variable average, which I didn't make a column for it, if you want to, you can make a column for average. Average is 8. And that 8 gets printed because of the print command, so you're supposed to show that here on your paper, and I always like you to circle the final values in these columns. So there's your complete answer for exercise number 1. Looking at exercise number 2, we have the same numbers being inputted, but there's no embedded if statement inside the while loop. That, I think, causes problems. Maybe you should trace that, of course, and do the exercise. I think the -1 might end up being added in to the sum, and I don't think the coder wants that to happen, because I think you want to add up these quiz scores, 9, 7, and 8, and divide by 3. And maybe even count ends up being high. Count might end up being 4, which also dilutes or messes up your average. I hope our school's grading software doesn't have buggy, logic error-ridden code like this. You'll never know unless you double check graded paperwork that's handed back to you and check it. Okay, I'm not going to do number 2 because that's just too good of a problem for me to give away the answer. See me after school if you need help on number 2. And number 3, I have a typo here. I'll probably fix it in a later version. But I have the variable num, and over here I wrote sum. You know what? Let's change this sum to num, and then we're good. So make this a num over here. 0, 0, 0. I'm going to start you out on this exercise, number 3. While num not equal to -1, that's true, so we do go through the loop. 9 gets inputted here into num, so put a little 9 there. Now we have an if elif, not just an if, but an if elif. So you start at the top of the if. Is num equal to -1? No, it's not. So that's a false. And the way if elif works, if else if. You trickle down to the first elif and you test its control expression and see if it's true or false. Is 9 divided by 2, does that have a remainder of 0? 9, long division divided by 2, that goes in that 4 times. We get an 8 here. We do the subtraction like you were taught. That's a remainder of 1. That is not a 0. So this elif is false. And then it trickles down to this elif and tests this control expression, which it's the same long division problem, but the remainder is indeed equal to 1. 1 is equal to 1, so this is considered true. and therefore we do execute the code that's indented inside that elif, which, by the way, is inside the while loop. Now, what's this telling us to do? Sum odds plus equals num. From right to left, this num gets added in to the variable sum odds, which you can kind of see in the video. It's kind of off there. And sum is currently 9. That's a 9. So a 9 gets added in here to this variable right here. Oh, what a coincidence. The number 9 is odd, and it just went into the odd column. Now we loop back up to the top of the while loop. This control expression is still true. So we get a new number from the user inputted, the 7. And we now evaluate the if, elif, elif. If you had to go really super fast, you can see by the tracing this loop one time, you can see that even numbers will have their values added in to the accumulator variable sum evens. All of the odd numbers inputted by the customer or user, they kind of get added into the sum odds variable. You can't have both elifs be true. It doesn't work that way. It's either one's true. The first one that's true causes the rest of them to be skipped below that. Besides, a number can't be both an even number and an odd number, unless 0 is considered both even and odd. I'm not sure. But anyway, these are the numbers 9, 7, and 8. Now look at what I did with the -1. The -1 eventually does get inputted here. I'm not going to show you when, but eventually down here you get a -1 for num. At that moment, when you test is num equal to -1, that will be a true, and therefore you execute the code that's indented below the if, and here's what the break does. The break breaks you out of the loop that you're in. It doesn't break you out of an if, it breaks you out of the loop that you're in. So it's pretty much go straight to go, go straight to jail, don't collect $200, don't pass go and all that, you go straight to jail. You don't execute any code here, and you don't even loop around again. It's like, like a ejection seat in a fighter jet. You're out of there. You don't get to land on the runway. You're out. So something prints then after that while loop terminates it when it breaks. And good luck with that, figuring out what the sum of evens is and what the sum of odds is at that point, since I did not do this whole problem carefully. That's what break does. Number 4, I'll give you a little bit of help in this video with number 4 here. Number 4 is for people that eventually have credit cards. You have a credit card, they have a limit. They don't let you spend like $1 million on a credit card. This one's only a $100 limit here. I made it a constant, kind of like with all caps. A while loop, of course, with a control expression that at first is true. The person inputs a 33, and then, oh, look at this. You haven't seen any of these on a worksheet yet. An if statement with something that you have to do by the order of operations. You have to add those two variables and figure out if that number is less than or equal to limit. Now, limit's 100. So you're basically testing to see if what you're about to buy, the current charge, at the store countertop puts you over your limit or not. If it's true, if you're less than the limit, then you do go into this if statement, and it does add the cost of that purchase to your total balance that you owe the store. So when we add 33 and 66, that's 99, which is less than your $100 limit. So I think it keeps going around this loop until you overspend, or better yet, until you're about to overspend. They don't let you go over. You'll learn when you have a credit card someday. They reject you from buying that last thing that you were trying to buy before you actually buy it. So good luck tracing that program. There's no break. There's no elif. It's just an if with a little bit of addition going on and a less than symbol. And it also checks for -1 because of the way an and works. it does kick you out of the loop at the right time, and it does not add the -1 in to your total balance. I believe it works correctly without a logic mistake in that way. Good luck.